In this last lesson of Unit 3, we are going to combine everything that we have learned in the previous lessons of this unit so far. We're going to be using the techniques we learned to solve for linear equations. We are going to use the methods that we learned for absolute values and also the techniques that we use in inequalities. So let's start. Let's solve this absolute value inequality that we can see on the screen. The absolute value of 4x minus 6 is greater or equal than 18. To start, same as with every absolute value equations, for inequalities, we also consider both the positive and the negative answer. Meaning, we have to write 4x minus 6 greater or equal than negative 18 and 4x minus 6 greater or equal than positive 18. We have both the negative and the positive solutions, as we learned in lessons 3.4. Then, when dealing with inequalities, with absolute value inequalities, the negative solution, the equation that we put the negative answer, so in this case the equation with the negative 18, we must take it and switch the sign. So we need to switch the sign of the inequality for this negative solution. What this means is, if this was greater or equal than negative 18, we need to erase it and replace it for a lesser or equal than negative 18. So always for the negative solution, we switch the sign of the inequality. For the positive solution, we leave it as it is. Now, we solve each of these inequalities individually. Let's start with the inequality on the left. 4x minus 6 is lesser or equal than negative 18. This is a two-step equation or inequality. The negative 6, the inverse operation of a negative 6 is a positive 6, and they cancel. And even in these complex situations, the golden rule of algebra still applies. If we do it on one side, if we added plus 6 on the left side, we have to add plus 6 on the right side. Now we do the operation. Negative 18 plus 6 is equal to negative 12. Then we take care of the 4 that is multiplying the x by dividing both sides by 4. The 4's cancel on the left, and on the right we have negative 12 divided by 4, which is equal to negative 3. So x is lesser or equal than negative 3 on the left side. Now let's take a look at the other side, the right side. What equation we have on the right side? 4x minus 6 is greater or equal than positive 18. And remember, this was the positive solution, so we did not change the inequality sign for the positive solution. This is still a two-step equation. Actually, we're going to follow the same steps that we did on the left. The only thing that's going to change is the final answer, because we're going to do plus 6 on both sides, so we can cancel the 6 on the left. And now we have 18 plus 6 on the right. But 18 plus 6 is no longer negative 12 as we have on the left. 18 plus 6 is positive 24. Then we need to take care of the 4 by dividing by 4 both sides. The 4's cancel on the left, and we get 24 divided by 4, which is equal to 6. So x is greater or equal than 6. These are our two solutions for this absolute value inequality. X is lesser or equal than negative 3. We did the sign change for this one because it's the negative solution. And x is greater or equal than positive 6. We did not change the sign for this one because it's the positive solution. But let's clean this up. Let's represent our solution. Let's use our number line so we know what this actually means. X lesser or equal than negative 3 and x greater or equal than positive 6. And for this, we're going to bring our number line again. We have two solutions, so let's do them individually. First, we have x lesser or equal than negative 3. So let's locate negative 3 in our number line. First, we can see that the inequality has the equal sign on the bottom. That little line on the bottom is an equal sign, which means negative 3 is included. Negative 3 is part of our solution. And then the x is on the close side of the inequality, so x is smaller than negative 3, which means our solutions are to the left of the negative 3. Now, what type of solutions we could possibly have? Well, any number that is smaller or equal than negative 3, like negative 5, negative 17, negative 527, negative 82.17, even negative 3.001. But what about the actual negative 3? Well, remember, we do have the little line on the bottom, which means x is also capable, is also able to be negative 3. So we include negative 3 in our solutions. Now let's focus on the right equation, x is greater or equal than positive 6. Let's locate positive 6 in our number line. We do have the little line on the bottom, which represents that x can be equal to 6. So we include 6 in our solutions. And then x is on the open side of the sign, meaning x is greater than 6. So x is any number to the right of 6. Now, what numbers is 6 allowed to be? Any number greater than 6, like 9, 28, 18, 48.93, 6.001. And then again, what about 6? We do have the little line that represents the equal. So that means 6 is included in our solution. So this 2 represents our solutions. Any number smaller or equal than negative 3, or any number greater or equal than positive 6. And with this problem, with this very complete problem, we finish Unit 3.